Less than 48 hours after a largely successful tanking test of its Space Launch System rocket, NASA is preparing to return it to the Vehicle Assembly Building at the Kennedy Space Center. NASA Administrator Jared Isaacman breaking the news on social media, describing an overnight helium problem related to the rocket's upper stage. If you're looking at the vehicle at the pad, the Interim Cryogenic Propulsion Stage, or ICPS, starts here with the white section showing the American flag and extends down inside the conical launch vehicle stage adapter. Isaacman used a second, longer post on the social media site X to expand on the issue, offering a preliminary assessment of the problem. Last evening, the team was unable to get helium flow through the vehicle. This occurred during a routine operation to repressurize the system, Isaacman wrote. We observed a similar failure signature on Artemis I. The Artemis II vehicle is in a safe configuration using ground ECS purge for the engines versus the onboard helium supply. It's too early to know for sure what the root cause may be, but Isaacman says it's likely not a filter between the ground systems on the mobile launcher and the rocket. He says other possibilities for the issue include a failed quick disconnect umbilical interface or a failed check valve on the rocket. Isaacman notes that similar issues to both of these scenarios cropped up during the Artemis I pre-launch campaign. In fact, in late April 2022, NASA had to roll that rocket back to the VAB because of an issue with a helium check valve that needed to be replaced. Regardless of the potential fault, assessing and remediating any of these issues can only be performed in the VAB, Isaacman wrote. As mentioned previously, we will begin preparations for rollback, and this will take the March window out of consideration. Those preparations began Saturday afternoon. Bright red platforms that were installed on Friday night to allow access to the flight termination system at the launch pad were removed and lowered. The emergency egress system will also need to be dismantled before a rollback can take place. A social media post shared by NASA spokesperson Bethany Stevens shows Isaacman getting a first-hand accounting of the situation out at Launch Complex 39B alongside members of the agency's Exploration Ground Systems team. Turning to the issue at hand, the Interim Cryogenic Propulsion Stage is 45 feet tall, or 13.7 meters, and measures 16.7 feet, or 5.09 meters in diameter. It's outfitted with 8 helium bottles that are designed to purge the engines as well as to pressurize the liquid hydrogen and liquid oxygen tanks. Isaacman says the helium system performed as intended during the first and second wet dress rehearsal fueling demonstrations in February. This upper stage of the Space Launch System rocket is manufactured by United Launch Alliance in partnership with Boeing and takes heritage from the Delta IV rocket's upper stage. The vehicle is powered by a single RL-10C-2 engine. NASA is using 3 ICPSs to fly the first 3 missions of the Artemis program. The ICPS that's flying the Artemis II mission was delivered to Florida from ULA's rocket factory in Decatur, Alabama, back in July 2021. It was brought out of storage in 2023 and moved to the Delta Operations Center at Cape Canaveral Space Force Station to undergo checkouts and processing. As part of the rocket stacking for the Artemis II mission, the ICPS-2 was formally delivered to NASA on March 9, 2025, moving to the agency's multi-payload processing facility inside ULA's vertical transport fixture. Once at the MPPF, it was loaded up with hydrazine for the stage's attitude control system. The ICPS-2 was then brought over to the VAB on April 15th of 2025 and subsequently was stacked onto the rest of the rocket on April 30th. The timing of when the full SLS stack will return to the VAB has not been announced as of February 21st, but Isaacman said in his post on X that the public should expect a, quote, more extensive briefing later this week as we outline a path forward, not just for Artemis II, but for subsequent missions. Reporting for Spaceflight Now, I'm Will Robinson Smith.